really excited to be here and share more about Signal AI and the technology behind that. And the meetup is called Show Me the Code. I'm not going to show much code, but I'll show, I promise you, very interesting architectural solution and mostly the mindset behind those architectural decisions to have an idea how we are supporting the growth of Signal AI over the last few years, and how we're actually driving that growth with technology rather than just following those decisions. So already 2,500 years ago, Heraclitus, there was a Greek philosopher said, the only thing constant is change. The word on that specific has not changed much, because this is even more true than in the past. The world was at a much slower place 2,500 years ago. But fast forward now, 21st century, society is changing very quickly. And the businesses embedded in societies are evolving and growing very, very quickly. And technology companies like Signal AI and like all the companies you guys are working in need to evolve and adapt to the world and to the needs of the business growing. So the question that we all have as engineers, as a technologist, is how should we deal with change? Because sometimes change is a difficult thing to deal with. And as a technologist, we have a great technology vision. We have our code, we have our systems, our services, and not all the time we are necessarily ready for that change. So how can we start thinking a change actually a lever of acceleration and growth, even from a technology perspective, rather than actually feel it as a constraint for ourselves. The first thing that I want to highlight is why change is so important in Signal AI. And I'm sure this is our scenarios where they're not just related to Signal AI, but by giving you in a moment of a couple of the flavors about what we're doing, you probably understand also the size of the changes and the pace and the speed of things are changing, evolving in the business, and therefore in the product technology, because at the very end, we are a deep tech company, so product and technology is the driving force of the growth. Signal AI is this transforming decision making. We are building a platform that is helping people taking better decisions. The volume and amount of data out in the world is way too big for any single individual, between newspaper, online, digital outlet, social, podcast, broadcast, you name it. There's way too much stuff for anyone to be on the top. What Signal is doing is ingesting a lot of these documents in pretty much real time. And then we use machine learning, in particular, we use natural language processing to start making sense of the amount of data. So we spot things that matter. We identify in any given document that we see, we identify people, organizations, locations, products, ingredients, and also identify topics. So things like innovation, things like sport events. So we're able to start creating a bit of a context around that. It's not just a piece of text. It's actually a text with some meaning. And whilst also following that, we interpret that data. When we identify that a document is about a specific person, a specific organization, we also understand what is the sentiment around that specific person or organization. Is it a positive sentiment or is it a negative sentiment? We started understanding how a company and a specific topic is they're correlated. Do we see a lot for a company be in the news with the innovation tag? So actually, probably the company has a very strong innovation brand, or actually we don't, or is anything that is concerning. And on top of this amazing platform, we build a number of products that serve different industries to take better decisions. The fact that decision making is an activity that we all take as humans. So by nature of the product, we can play in different industries by using this NLP and the support of user that can also train some of these NLP themselves. Now, this is it's a power platform, but there's a lot of technology behind that. And just to give you a measure, we ingest about 4 million documents a day, so it's a fairly high volume documents from a variety of sources. So we just don't ingest traditional media like newspaper, but we also ingest broadcast, we ingest social data. And overall, we see up to 4 million others, and it's keep growing. But it's also a fairly high throughput system. The mean time of ingestion is about 30 seconds. So this is an interesting one, because if you take the 30 seconds in isolation, it feels slow, but actually it's quite the other way around. If you think about it, that means that every given second we have, as average, about 50 documents that are fully classified. And on any given document we receive, we run hundreds of different machine learning models against it to really make sense of it and extract value. Also, documents don't have an even distribution. So it's not that every given second we receive the same amount of documents, because we follow the cycle of events in the world, especially with the news. If something big is happening in the world now, in the next half an hour, there's going to be a crazy amount of data coming through the digital outlet. So that distribution over time, those spikes, is something that from a technology perspective, we have to be able to absorb. So the 30 seconds is actually the average. That means that most of the time we ingest these massive amounts of data, fully classified with 100 of machine learning models, like in probably 5 to 10 seconds. The 30 seconds actually when our technology has to kick in and auto scale to support the spike to respect that internet SLO. So there are a lot of moving parts. It's not just the business that is moving fast and experimenting new things, but the technology itself has to grow. I talk about this, right? So as a business, we work on many dimensions, right? We talk about the real time. We like our SLO near real time aspect. We want to maintain it. The scale in the content set is keep growing. It's 4 million documents now. In a year time, might be double. How do we deal with an extra 4 million documents? What do we have to do as a technology to support that? We are a deep tech. We work a lot with machine learning. We have a research team working very close to our engineering and product team. How do we keep innovating and scaling in the NLP space? How do we allow the research group to experiment with the real data, with new models to validate that we achieve the right quality? And the ability to play multiple markets is an important thing for us, right? We said it is a decision making is a horizontal capability. Although we started with a specific industry from a business perspective, we need as a business to play on multiple markets. So how do we support a business in rolling out products in different markets? So keeping all this in mind, how we deal with all these changes, a lot of changes. There is business needs, there are technology needs. How do we deal with that without becoming the blocker to the business? And actually, the only way is about embed change in your software as a core principle. And this is something we started from the beginning, but over the last years, it became much more a first-class citizen in the way we think about designing the software, we think about architecture, and as a consequence also how we design every single service in our microservice architecture to support this principle. So naturally, when we think about an evolving system, our mind, went close to evolutionary architecture. So evolutionary architecture, for who is not following that, is a set of principles about how to think of your technology system, all your microservice architecture. It doesn't have to be a microservice. It could be any type of any system, in a way that will allow change, support change. So pretty much we create a system is built for change, is built for change. And there are three main pillars to support that. The first, it has to be incremental. So, system built with an evolutionary architecture mindset are built one part at a time with many different increments. And the speed between one increment and another is the key. So not all the time is easy to improve that, but it's an important thing to keep in mind. If you're building for change, what you're doing is setting yourself up for easy change. Easy doesn't mean automatically short or anything like. It means faster than otherwise. It might still take you 5 months or 6 months or a year, but the fact is those 5 months are probably half of what will be otherwise required without that mindset. The second pillar of evolution architecture is really around defining a fitness function. And this is, in my opinion, is one of the most critical elements to embrace when you want to have an evolutionary mindset in the way you think about your product. So every single system at a different point of life need to optimize to be fit on a certain environment. And systems and code are evolving over time. And We talk about technical debt. I think is an unfair definition actually for what we do. I like to talk more about different generation of system, because technical debt has an implication that we did something bad in the past. That's not the case. We're just evolving the system to the next generation of requirement or expectation. And fitness functions are very effective in this way, because what you describe is your final fit state where you like your architecture to go. And in one way, it works a bit of as North Star to move in that direction and achieve the final current state of fitness for your system or your service. And at the same time, it gives you also confidence to understand how far you are, because being an incremental system, you do not expect to achieve your final stage overnight. It's okay to achieve it over time, as much as you keep measuring what are the fitness function elements that you have in mind, and keep evolving in that direction. The interesting element, because we're talking about generational changes, right, is no more about technical debt, it's about different generational code and software. Your fitness function can and should change over time. The moment you achieve the fit level that you describe now, you pretty much achieve the right generation of your software system or your code for today. But if it's 6 months, you have to move the system to the next stage, to the next generation, your fitness function will change, and the fitness function can be everything that makes sense to you. I'm going to give you a couple of examples in a second, but I think anything that will make sense, from scale, to security, to open up new business opportunities, to performances. It's up to you. Whatever is the next stage of development and growth and how you want to evolve your system, the fitness function is there. And the third pillar for evolution architecture is really about being able to think in multiple dimensions. Evolution architecture is all about technical and domain changes. It's not just about technology. It's not just about the business domain. It's supporting both. The best approaches to the evolution architecture is be able to support and drive the changes that the business is want to achieve, is pursuing, with a technical mindset and the ability to describe what's required to support everything. Often, cross-functional requirements are a great example. Security is a good example. Performance, another good example. But what if we want to open a new market? How do we make that happen through our technology design? So keeping that in mind, there are 3 areas that are good examples of how we use that mindset in Signal, and how they help us think differently, but also how we use our ways of working, our principles and practices to support evolution architecture. Because you can have a great session about architecture design or service design and start writing the code, but what are the principles and the practices that you put underneath to supporting, actually not just supporting your incremental mindset, but actually accelerating and boosting it up. The first example of evolution architecture approach in Signal AI is a pipeline that became a platform as a service, so a PaaS. If you remember the initial picture I shared with you of Signal, there was a big box where actually we start doing all the classification. So given a document as ingested, we are applying all these models, hundreds of machine learning models, to extract meaningful metadata that are enriching the single document, so that we go from a document with really no context, we don't know what it's about, to a document with a lot of context, with a lot of information and a lot of relevant metadata to help people make the better decision. And correctly started as a normal pipeline, because at the very beginning, in early stage of Signal AI, we were only working with a single data set. We were working with media, traditional media. And that was a traditional pipeline where a document was coming in, and there was a number of services where the document had to go through. And it was like a document that was doing entity extraction, and now they was doing entity linking, and now they was doing topic extraction, and then it was about sentiment analysis. And at the end of this conveyor belt, we were saving on our database. In particular, we've been always working with Elasticsearch. We keep working with Elasticsearch. It's a great piece of technology. But there was this conveyor belt of event that would allow us to go from a document, a lot of text, to a lot of text information. We understood actually, because what we're building is a bigger and a more ambitious platform about helping people take decisions, we had to introduce a different level of abstraction. So we moved from having discrete services the entity extraction to entity linking, to a number of capabilities to create a platform. So right now also we have a platform and we talk about what are the inputs API. So if before the way to pass a document to the system could be only one and only one, now we can think about have multiple ways to introduce the content to the platform. Why this is important? Well, first, because they will allow us to deal with different type of content set with a different velocity in the industry in different ways. Second, because by having different ways to introduce documents in the system, we also give ourselves the flexibility to open up new business opportunities, how to make the platform even a more central constant in our system. And we talk about routing, we talk about serving, we talk about scaling. So we change the level abstraction, and by changing the level abstraction, we also help ourselves to have different implementation. And if you think about the three pillars about evolutionary architecture that was shared before, we've been able to answer some of those very effectively. We are able to maintain our near real time because now we have a much more sophisticated platform that is evolving, so that we can actually have more flexible scaling and more effective scaling because we have a different granularity of the services. We're able to ingest diverse content set very effectively. Now we can always plug in new content set, and we can have a very effective way for route it through the system to the right machine learning models until they're ready for being stored or distributed in another way. And this is also helping a lot about NLP experimentations. Our engineers and our researchers can really push the boundaries of what NLP can do in helping people taking better decisions by creating new models, deploying it in a system. The platform now is able to manage the routing of different documents to specific systems in a very effective way, in a more programmatic way than not. And so people can very quickly see how this is working effectively. From a fitness function perspective, I said this is probably, in my opinion, one of the most important effective things about evolutionary architecture and how to think about. Well, we start being able to measure much more effective the ingestion performance. If before was a bit of a conveyor belt, so there was a compound value of ingestion, from S1 to S4 to storage. Well, now we have better boundaries around the ingestion and the performance. Of course, cloud cost management, it became also easier. We have better understanding of the different discrete phases of the system, and it's also helping us by measuring it. First, we can set ourselves some target, but also we can be much more proactive, understanding if actually serving is becoming a problem more than anything else. What are the options about making it better? Finally, evolutionary architecture is all about supporting, business and domain, and lead time for us, and definitely for me as a technology, is super important. We are in business and moving fast. We want to innovate at pace. We really want to move at pace and experiment in the market with new ideas. So the lead time is from a team, a person has an idea, to when this idea is into the market and is monetizable, right? As a technologist, how do we make the lead time as short as possible? How do we empower people to be as fast as possible and innovate? And transforming the pipeline to a platform is actually empowering all the teams that are, aligned to specific markets, so there are market, aligned kind of teams, to really work effectively, create new models, deploy in the platform, and keep moving towards their goal and serving their customer. In the same way as a technology, we use our cloud provider with certain building blocks, translating with evolutionary architecture principle, the pipeline to pass, help us a lot in that direction. The second example that I want to talk about is our front end. We apply the same principle that we use in the big platform that is about ingestion to the front end. And as before, we started with a very clear goal in mind that was serving the PR and comms industry to help them take better decisions. But along the way, in the same way for the big platform where all the models run, we understood that our system, our product is much more flexible. It can be served much more many markets. So how do we support the business for multi-market innovation? Well, we start working on a micro front-end architecture where actually we have number of a micro front-end that can be managed by different teams. So you have like in various Conway load that you can apply, and potentially also working on components that will support that. In the same way as before, we've been able to support the business. Actually, we're accelerating the business into moving into multiple markets. Right now, we have a better articulation on why it will be, how long it's going to take to go in a new market if you want to build a new micro front-end, a new model. At the same time, as before, product experimentation is absolutely there because we allow different teams to start and play with new market and test new ideas. The fitness function are very similar. Lead and cycle time, I mean, again, it's change. So we want to embrace change. And part of embracing is accelerating our lead and cycle time. But also at the same time, we start measuring the performances, low performances. The moment you have micro front-end, your bundle size will go smaller, so we'll get even better performance. And to a degree, error budget. We're going to be in a place where actually in our single page app, we have a better understanding of something does work because it's better modularized. And therefore, we can have a more controlled approach and have also overall a better experience. And I talk about these two examples, but as I said before, you need also principles and practices to support your evolutionary mindset beyond the architecture. And so what we need the Signal AI, we adjust end-to-end to that mindset. Continuous delivery, it's a critical one for us, and we really push it to the edge, as we really believe in trunk-based development. So we really encourage everyone to work on short-term living branches and continuously merge back to trunk or to master, so that we're all aligned on the code base. No one is behind, so integration is not becoming a problem. The second thing, in the same way for continuous delivery, we really want and we really focus on working as close to production as possible. We work heavily with feature flags. So when you build a new system, you actually going to deploy in the actual production system behind the feature flags. We don't work a lot with staging environment. Even if it's internal use, we encourage people to put it in production behind a feature flag. So the system is going to start being stressed by the volume and the size of the usage, and we'll get immediate fast feedback so that our architecture will change and adapt also based on those feedback. We fully embrace DevOps philosophy. So you build it, you run it. Each team is responsible for the build and the systems that they create. And this is very important because in the same way you want to build and evolve your architecture, you need to understand what are the elements that you want to change. And by have the ability and the requirement to take care of your system when it's live and in production, you have a number of very useful feedback to understand how to change it down the line. And of course, the right tool for the job. This is a list of some of the tools that we're using, but really it's about helping people to say, if you want to be incremental, you want to be a change mindset, go and find the right tool for the right job. I think that the best example that is around data stores. We have a number of data stores that will help us understand what is the right data modeling that will allow us to change and evolve the system at any given point in time. And the interesting part here is that if you look at data modeling, the right data store might not be the one that you think immediately about, because there is in an incremental and evolution architectural mindset, you really want to think about what is the right data store for a given point in time. One example is that we've been working for the last period over a knowledge graph, and more and more connect the different concept and principle in our system for discovering unknown unknowns. And naturally, there's a place in time where actually, a GraphDB is the solution. So it could be Neo4j. But at the very beginning of this exercise and experimentation, it was not based on Neo4j or any other graph database. We actually work with a mix of Athena and PostgreSQL, because there was enough for the volume of data experimentation we were doing. While we knew that it was enough to serve, we knew that the long term was about Neo4j or any other solution. So again, we use the evolution architecture mindset to embrace change and really see the different stage of architecture and software design and software and coding based on what we need. So the reality is, like, we need to want to embrace change. And the way you want to do as a technology system is really a technology company is to be proactive. If you're proactive as a technology team, you're going to lead the change. And exactly this is one of the secret sauce of a fast growing business, right? Evolution architecture is our way, a signal way, but it can be used by, in any other context to drive the changes, right? We adjust our ways of working, the way we work, the trunk-based development and all the other techniques to support and enhance their mindset. All what we want to have is having a malleable system that will make changes easier, whatever time will take, than not have a clear direction of changes and flexibility evolving over time. So the other thing is like, yes, we started saying the only constant thing constantly change, and this is just a fact. And the way to deal with it is, embracing it and using to actually drive the business, open up opportunities, and help everyone in technology, outside technology, to really think in a way to really innovate and push the boundary. And hey, if you guys are interested in these problems, we're growing. Come have a chat. We're hiring and we're keen to meet a lot of you. Thank you.